Right, so we have a trapezium, but looking more closely at this question, we see these things on the diagram, and this notation here, OP, PT, and OR with the lines above them, and this is a vectors question. Okay, so what can we do? Well, the first question asks us to find OT, and what we tend to do is we look at OT, there it is, there's nothing marked on there, so we think, how do we get there? Via vectors we do know. Well, we know O to P, and we know P to T, and that gets us from O to T. So that's what we do. We say OT is OP plus PT, and write down those vectors in terms of A and B. Well, they are, in fact, A and B. And so OT is very simply A plus B. And then we do a similar thing for PR. Where's PR? That's this vector here. How do we get from P to R? Well, I would go back to O and then out along to R, and that would seem to be using things we know. So PR is, well, let's go from P to O and then from O to R, and that's the route we're going to use. So PR is, well, PO is, well, it's sort of A, except it's going the wrong way, and backwards along a vector is minus that vector. And then we add OR, which is 3B, and I can either leave it like that, or I could write it as 3B minus A. I'll just leave it like that. Okay, doing well so far. Now there is a whole nother page of questions, though. Here they are, and you'll see I've repeated the diagram, just so we don't have to keep flicking up too much. Now, what are we told? We're told that S is a point on PR, so on this line here, such that PS to SR, that's a ratio, is 1 to 3. So it splits the line. Let's put a point on here. Let's put it on in blue. There's a point S, maybe there, so that the ratio PS to SR is 1 to 3. Now let's just think about what that really means. It means that PS is a quarter of the length of PR, because I've got 1 to 3, that's a total of 4, and PS is a quarter, therefore, of the way along from P to R. I just write that down in case it's useful. There it is. Right, let's see what they really want us to do. Find OS. Right, so find OS, that's this vector here from O to S, in terms of A and B. Well, how do I do that? Well, I think I'm going to go from O to P, and then because I've just found PR, I can go from P to S and use the fact that PS is a quarter of PR. So what do we get? Well, O to S is therefore O to P plus P to S, as we've just discussed on the diagram, and O to P plus P to S. Well, P to S is a quarter of PR, and that's the one we know. We'll flick up in a minute and see what it is. But O to P is A, and P to R is, well, we've just found that. Oh, there it is. It's minus A plus 3B. So minus A plus 3B. And let's multiply that out because it asks for it in its simplest form. So we'll do that now. So that's A minus a quarter A, and then a quarter times 3B. I'm just multiplying out the brackets as I normally would. There's a quarter times minus A, and there's a quarter times 3B. And a quarter times 3B is 3/4 B. And so A minus a quarter A, I'll take a quarter off 1, you get 3/4 A plus 3/4 B. So there you go. And what does our answer to part B, that's what we've just found there, tell us about the position of point S? Interesting question. Right, well, let's write this in a slightly different way. Not like that, but with a red pen. OS is, well, look at it. I've got a common factor here of 3/4. So that is 3/4 of A plus B. And if we look back up the page, we should recognize that, oh yes, OT was A plus B. Okay, let's get that in the right place. And we can say since OT is equal to A plus B. What does that mean? Well, that means that OS is 3/4 of OT. And so we've got, I just get rid of these marks, we've got two vectors, both of which have an O looking on the diagram, and OS is a multiple of OT, which actually means, unlike my diagram, those two vectors are parallel. And since they're parallel and they share a common point, that means that S lies on OT. And that tells us about the position of point S. Jolly clever.